Applications often rely on a specific environment, a certain operating system. The absence or presence of other applications or libraries can be crucial for whether they can meet the requirements to run properly. With Docker, applications can be compiled into their own environments in a package known as a container and made operable on different systems. These application packages can be easily shared, and running multiple such containers simultaneously on a system is not a problem. And Docker is now available on all major operating systems, making the containers operable regardless of the operating system. In the field of geographic information systems, Docker has become indispensable as it simplifies the smooth development, deployment, and scaling of web-based GIS infrastructures. Experimenting and learning with new innovative tools for geospatial data processing is also easier in isolated environments where various GIS applications and versions of tools can be matched and made available independently of the operating system. For a simple understanding of this technology, let's follow the creation of a Docker container in 3 steps, from the Docker file to the image and finally to the container. A Docker file is a text file containing instructions on how to build a Docker image. Think of a Docker file like a recipe in cooking or a blueprint in construction. What user environment should our Docker container be based on? Should it be discoverable on a network as a server? Is a runtime environment for a programming language necessary? Should the container have important data available from the start? All these decisions are specified in the Docker file. Once all the necessary components of a container are described in the Docker file, Docker is instructed to compile these into an image. Each component described in the Docker file is gathered and stored in the image. It contains all the necessary components and information to create an operable container. Once created, images are immutable and can be shared among users and downloaded from public repositories like Docker Hub. A Docker image can also be thought of as a kit that can be copied and used any number of times. It has everything needed to assemble a working model. But the kit is not the model itself. Only when this kit is assembled, following the instructions, using the included components, does a functional instance of the model exist. And since the kit is copyable, another instance can be built, and another, and another. And so, with the correct command on a system where Docker is installed, the image becomes a container, an operable instance of the image as an isolated working environment, including its own file system, running processes and applications, regardless of the operating system, and, if necessary, a second one or a third. Docker enables the provision of entire application environments on different systems using isolated containers. The development and implementation of sophisticated geographic information and analysis systems are thus facilitated. Moreover, isolated Docker containers open up diverse possibilities for learning and experimenting with geospatial data. The Docker file contains all instructions for Docker to create an image. This is immutable and can be easily distributed. A Docker container is an instance of this image and can be started on any system where Docker is operable.